manning the Zoom here, doing a lot more of the back-end work. But our presenters today are Mike McFarland, our VP of Product with Benu. Mike, if you want to say a quick hello.
I have about 20 years of experience in the telecom industry, and very excited to walk you through some of the new solutions that we have developed both within Benu and jointly with Arista.
And then, as I had mentioned earlier, we also have Christian Martin. If you want to say a quick hello as well, he's the VP of Service Provider Customer Engineering at Arista.
Thanks, Saoirse. Hi, I'm Chris Martin. As Saoirse mentioned, I handle the service provider technology side of the business at Arista. Also very excited about this discussion, especially as to how hardware acceleration can move NFV in some environments to provide better capabilities and reusability of existing assets around service creation.
Awesome. So I'll actually hand the mic off to Mike to get us started and give you a little bit of an idea of who we are from a Benu perspective, what we stand for, and what our product line spans.
Great, thanks, thanks, Saoirse, and thank you, Christian, for joining us today. Just a quick sound check, because it's a little bit choppy on my side, but can you guys hear me okay?
You sound a bit choppy, Mike, just now.
I do, yeah. Yeah, okay, it got choppy sort of just as we've started things here. So let me do an intro slide here, and let me know if it's still bad at the end of the slide, and I can always try and connect over a different method. So Benu Networks is been around for about 10 years now, established in 2010, and we do have global offices headquartered in Boston. We are a well-known industry leader in Wi-Fi access gateways, and we're a very engineering-led company with about over 80% of the employees, and so we really take R&D and innovation very seriously, and we work very hard to support our carrier customers in making sure they have the right platforms and services available to them. And in terms of our deployments, we are deployed globally, probably mostly in the U.S., Europe, and Latin America. And these deployments are with both big and small carriers. We do have a lot of traffic going through our software and hardware platforms, so roughly about 7 petabytes per day, which is trying to figure out if 7 petabytes is a lot on a daily basis. It turns out it is quite a bit. It's more than all the North American mobile operators combined. And about 24 million connected Wi-Fi APs. I'm going to actually turn this over to Christian now to talk a little bit, and I'm going to try and connect to a different audio.
Thanks, Mike. I hope everybody can hear me okay. Let me just give everybody a brief introduction to Arista Networks. We've been in business now for about 15 years. Just as a highlight, sort of the numbers, Arista by the numbers. I don't know what happened there. Looks like I lost control now.
Hold on one second. I'm trying to connect to the computer audio. Shoot.
Apologize, everyone.
Yeah. Okay. All right. Sorry.
Let me see if there we go. So we have about 44% of the 100 gig market share. So this is #1 in the industry. Our annual revenue last year actually was more line of 2.4 billion. We're at about 18 billion market cap. One operating system across all hardware from the beginning of the company, with the exception of the Wi-Fi access points, which are kind of a different ballgame. But all the switches and routers that we build are all on the same operating system train. The company was founded in 2004 by Andy Bechtolsheim, David Sheridan, and Ken Duda. Andy and Ken still work in the company. Andy runs, he's our Chief Development Officer, and Ken is our Chief Technology Officer. Company was self-funded by Andy, David, and Ken, specifically from David and Andy. As many of you know, the history there, Andy and David were the first investors in Google, or at least I think they're the first major investors. There might have been some private investment early, but they were the first non-private investors or family investors. And with that, obviously with that kind of investment, you tend to be able to self-fund a company for a long time. And that's useful because you don't have the same external pressures. And the goal of the company was able to be better achieved. One of the keys is the mission to transform networks from these static, closed proprietary systems to networks that were much more programmable and automated and performant and cost efficient. And certainly the goal was to make them platforms for service delivery. Next slide. So as I mentioned, we were founded by a bunch of engineers, right? So that, as often is the case. And that culture has stayed true through, from the beginning of the founding of the company to the present. So the goal was to build a company by engineers for engineers. It's an engineering-led culture, just like Benu. More importantly, the entire culture of the company is driven around quality. And quality is very much a cultural thing. It has a lot to do with architecture of the systems, and a lot of software quality is contingent upon having a very aggressive and automated testing regime. So all these things we brought in from the beginning. Our developers write the code, they write the test plans for the code, then they write the test cases for the code, and they execute the test cases in unit tests, and then all of the software that is written at Arista is checked in immediately during the build process into the automated test system. And those tests run indefinitely. So the tests that we were running back in 2010 and 2009 are still running today, because that's how you defend against things like regression bugs. And in the history here at Arista, we've only had 5 regression bugs in 15 years of EOS development, which is a significant quality metric. And that's really shines through in the way we do things. The Arista advantage for service providers is this quality over everything else. And our networks, customer networks quality and performance is always our #1 priority. Next slide. So from the beginning, the company was founded to build a better operating system. There was no desire to build hardware necessarily, or certainly not to build a new kind of hardware architecture or anything like that. So that meant merchant silicon. We'll talk about that in a moment. We wanted to build an operating system that was well understood by the community of users that we were serving at the time, and still are serving to this day. So we built it on Linux. It's an agent-based or daemon-based operating system. We have a centralized stateful database that maintains all system state. So none of the interprocess communication for retrieving and sharing data is done directly. It's done through this database. So it's a sort of a publish and subscribe model. And that makes the system inherently more reliable, and it's easier to build, and it's easier to develop software in a continuous integration and continuous deployment like pipeline, because you have small groups of teams building software around a common data model. And then hardware abstraction on top of all the different hardware that we build on top of, which is really an array of merchant silicon switches, and is, of course, is always the case, a virtualized and containerized version on x86. The benefits here are fault isolation and fault repair, which should be something that, of course, everybody cares for, as well as the ability to do things like in-service software upgrades. And because it's agent-based, and because it's Linux-based, and because we have an SDK that allows you to write to this net database and interact with the agents on the system, it's very welcoming to third-party integration. So you get seamless integration. We have customers that are writing their own routing protocols and their own traffic engineering tools directly on our switches. And one of the things that we'll talk about here is how we can use this SDK to build a partnership with a company like Benu for them to provide the control plane and us to be able to provide part of the data plane for a select set of flows or even all flows for a particular set of subscribers. Next slide. Now, emergent silicon is something that you hear a lot about, and it's something that Arista talks a lot about. And part of the reason this is the case is because where we are today, service provider routing and things like high concentration of users in the broadband access case, where you need things like hierarchical QoS and shaping and policing and being able to apply policies, you need hardware acceleration, and the silicon that's available to us today is at the point now, and it's really been there, but it's now at the point, especially in 2020, where just the chipsets that are available to us, the capabilities that they have, especially when you really try to build in new capabilities or to come up with creative ways to do the silicon programming, are put to the test. And Arista's been doing that for the past 12 or so years with our first shipping products in 2008. All the way up till now. And the Jericho 2 chipset and its subsidiary chipsets, the smaller carved out ones that you'll see over the next several months, have all the capability needed to do high performance service provider class routing at scale. Next slide. Okay, Mike.
Alrighty, so I'm actually gonna hop back on just to walk you guys through, because I don't know where Mike is at in terms of with his microphone here. I know he's having some struggles with that, but now that you guys have a little bit of insight as to who we are, both from a Benu perspective and from an Arista perspective, hopefully this will make a little bit more sense when we're talking about our joint solution and why it made sense for us to come together and what sort of benefits we can offer you from both a hardware and a software perspective. So as we walk through today, some of the things that we'll go through are the current customer needs and the network gaps that exist in your current architecture. So essentially saying, how did we get here? What are some of the trends that bubbled up as the years went by that kind of are now putting people in a position to say, I think we really need something else that gives us a little bit of flexibility, and how do we go forth and do that? And so after we talk about that, we actually will touch on how you can switch from a VRAS or a typical BNG to something like a vBNG, which is what we offer, and how we work with Arista to make that solution even better and even more amazing for you guys and easier to get set up and really be able to deliver value-added services to your customers. And then finally, we'll wrap up with some of the value-added services or use cases that we typically see with our customers, some of the new things that we're seeing, and how you get started with those, and really what the benefits are of being able to offer those value-added services. And so as I had mentioned before, we're really looking to make this more of an open conversation. If you have any questions, please just let me know, type it into the chat, and we'll get started. So before we switch over really quickly, I actually have a poll for you guys. So you should be able to see it pop up on your screen. We kind of wanted to get a feel for our audience, obviously, and really understand, are people currently looking to replace your incumbent BNG and your VRAS, or are you trying to get more information from the market and see what's out there in terms of laying the foundation for making a change in the future? So it looks like we have a pretty even split at the moment, which is good. Okay. Alrighty, so I will leave this up.
Shusha.
Yep, how's it going? Okay, great.
Do I have a better voice connection now?
Yeah, it does sound a lot better.
Oh, wow. Yeah. Okay. All right. Well, this was not planned. Very timely though, because there's a lot of people, doing working from home, teleworking. And of course, that's one of our use cases here on the right-hand side, which is, working remotely, and some of the challenges that can come into play when you're trying to use internet connectivity with a whole bunch of other people in a house. And so obviously there's opportunities here for broadband providers to kind of further differentiate their service. Perhaps I need to call my broadband provider about this, and providing some prioritization for people that are doing webinars or video conferencing or voice calls versus other traffic that might be going on at the home. And then the other thing, of course, that's happening is there's a big increase in use of IoT devices within the home. People are starting to use things like remotely controlled locks on doors, things that have to really have better security from an internet security perspective. And so this is another big opportunity for broadband providers to just add additional security services for IoT. Of course, there's more and more reliance on cloud-based and network-based services. And so the reliability of the broadband network is very important. And then, of course, as people use broadband and online services more and more, there's opportunities for broadband providers to enhance those services. So it's all about really capitalizing on this opportunity and moving beyond kind of what your traditional broadband remote access servers can provide. Okay. So some of the challenges with the current BRAS and BNG solutions that are out there is, first of all, frequently there's proprietary hardware solutions which make scaling, up or down. Sometimes you want to scale down to a relatively low capacity, but at a very cost-effective price point for smaller POPs. So that is certainly one challenge. Lack of flexibility in managing the control plane and the user plane. And when you think about it, control plane oftentimes should be scaled, at different rates and differently than the data plane. And so being able to separate those two, manage them separately, provides a lot of, flexibility for operators. The need for higher bandwidth to qualify for government funding. So, just recently, the government has, here in the US, has passed a bill that's going to allow for up to $16 billion. I mean, this is unprecedented amount of money, $16 billion to basically go towards funding primarily rural deployment of broadband. And there are certain speeds that have to be deployed. So it's going to be mostly going to have to be done with fiber networks. And advanced services, is complex to add usually on these platforms. So having something that is flexible that can allow you to add services more easily. So let's just talk a little bit about sort of the baseline features that you typically see in a broadband network gateway or BRAS. So for PON or fiber networks, usually you see Q&Q access technology using IPOE. Also, a lot of networks use PPPoE, whether it be over sort of legacy access or for wholesale purposes, PAP, CHAP authentication, DHCP. HQoS is referring to hierarchical QoS, which allows for carriers to provide a specific speed to the entire home or business, but then also provide differentiated bandwidth rates for the services going into that individual home or business. Of course, routing and virtual routing and lawful intercept for lawful requirements. These are kind of the baseline things. But really, a lot of carriers also have to implement additional platforms to either layer on services like the service gateway. They might want to do deep packet inspection like DPI. They may be doing carrier grade NAT functionality if they're using a private IP address space for the homes and businesses, and then sharing public IPs among the homes. So that's a way to, of course, reduce cost in terms of number of public IPs that you have to purchase. So all these nodes, though, create higher cost, higher latency. It's also creates more complexity. And it's generally a suboptimal architecture, and this is what some carriers are having to deal with. So we take a different approach, and of course with Arista, using one of their switches to provide the aggregation of the traffic from the PON networks or DSL networks. And then within the Benu Networks platform, we're providing basically all those functions I just talked about. So vBNG function, the service gateways, the CGNAT, advanced services. We can even do access gateway function, which is related to 5G policy planes put onto a fixed access network. And so this drives lower cost, certainly have lower latency in terms of your traffic treatment and throughput. You have better inter-service awareness among the different services. There's more flexibility and service agility. So in terms of figuring out who you want to partner with for this kind of next-gen broadband access, you want to look at a couple different things. One is, the flexibility of their architecture and the performance that they can provide. And then, and that comes, in different layers, right? So there's virtualization, which of course the market's moved towards, and using DPDK, which is a technology for accelerating the forwarding of the packets within off-the-shelf, Intel-based servers. And then there's CUPS, which is, CUPS is referring to control and user plane separation. And so that's where you're allowing yourself to manage the data plane separately, or the user plane separately from the control plane, scale them differently, maybe even have them in different spots. But then the next step is doing hardware acceleration. And that's one of the things we're going to talk about today with Arista, is leveraging an Arista Switch to basically provide very high bandwidth services at a very low cost per bit, in order to support, the increasing needs of people's desire for higher bandwidth. The other aspect, of course, is the value-added capabilities, like CGNAT, WAG is for public Wi-Fi access, or guest Wi-Fi access, deep packet inspection. And then the services, so service function chaining, you could be chaining network services, like security or a static IP address or some sort of guest network capability. It could be user-based services that are specific to a device, so specific IoT security or specific bandwidth prioritization for teleworkers, parental controls that are applied just to the kids' devices but not to the adults. And then, of course, going even further as well, if you want to implement those services, you have to have some way for the end users to set them up and configure them. And so having home or business self-service portals that are already prepackaged and available for you is really something that helps operators, reduce their cost. So what does the landscape look like for this? I mean, most proprietary hardware vendors sit in kind of this section of the value chain here. They're providing some capabilities on the architecture, some on the value-added capabilities, but what we're trying to do as Benu and Arista is deliver the whole set. So get you the benefits of hardware acceleration and very high bandwidth capabilities, along with also providing the rich services that can drive additional revenue streams. So we want to get into sort of how we do this. And what does this joint solution look like? So first, let me just introduce what the Benu platform looks like. So we are basically able to handle a wide variety of use cases on the broadband access side, ranging from residential to MDUs and venues. And then connecting into our platform, where we have our network functions, and then we have subscriber policy services. And then, of course, most of that traffic is either headed towards the internet, or it's enterprise VPN traffic, or it could be going towards 5G converged core if the operator is doing a fixed mobile convergence. And then the other thing that we have is the Benu Cloud Management, which is used for managing not only our platforms, but also for providing those the infrastructure for the layering on those services. And this is a little more detailed look at the architecture. So we support a variety of our data planes. The Benu data plane can run on bare metal servers, could be on a hypervisor. We support both VMware, OpenStack, and KVM. We also have a NetOS solution it could run on. And then, of course, there's the Arista Switch, where we would program flows into the Arista Switch. And the other thing is we have these services on top, like managed home and managed business. And here we've shown a grouping of, 7 or 8 services that could be applicable to managed home, and another, 10 or 12 services actually that could be offered for managed businesses, or some people are referring to this as like SASE, Secure Access Subscriber Edge, kind of a new hot area that a lot of businesses are starting to adopt. So just to give a high level view of, how this architecture works, from, starting off with our platform. There's the Benu platform, and then you have the Benu platform is identifying flows, and some of those may be elephant flows, and those are perfect for hardware acceleration. So that's where the Arista Switch would come in, and we would actually use the Arista Direct Flow API to program the switch to handle the flow independently. So this is where the traffic is getting offloaded. And once it's been offloaded, the Arista Switch can send us telemetry, providing the connection details and statistics for the billing. And also HQoS can be implemented there as well, weighted round robin. So I'm going to hand this off now to Christian to talk a little bit more about how the Arista platform fits in.
Thanks, Mike. So I think I should be able to advance here. I'm not seeing it happen. So for some reason, let me see if I can, there we go. So, from a service provider perspective, we've, and just generally from a routing perspective, we've been building, we started out building data center switches, and then we really started to power the rise of the cloud. And part of that included our biggest cloud customers asking us, hey, can we get some routing capability here? And instead of coming to the market with a new set of platforms, really we just enabled routing capabilities on the existing platform. And as I mentioned before, the merchant silicon that we have available to us today is completely capable of meeting all of the demands of a service provider environment. So we have merchant silicon today, and we've built the capability to do more than 2.5 million routes in the FIB. With an external TCAM, we can go to 5-7 million routes. This is again in the FIB, not just in the RIB. At least 20 million BGP paths under all sorts of policy combinations and peers and RIB outs and multiple protocols running at the same time. 512-way ECMP for the largest scale leaf spine networks, of course, and then all the EVPN, MPLS, and segment routing, and RSVP and QoS that a modern service provider would need. And this is all written over the past 3 to 4 years. So this is the most modern software stack on the market today, especially given the features we have. We've crossed so many traditionally very difficult to cross thresholds, being able to get to 20 million BGP paths, for example, and 500 peers, or being able to build a full RSVP TE stack with all the bells and whistles. And very few vendors have done this, certainly not recently. And this is a testament to our commitment to this market. If you can advance here, so through the end of the build. So we have a modern OS, as I mentioned, lean OS. It's Linux at heart, full set of tools, so you can do everything that you can in a Linux environment. We just so happens that there's a CLI running as a shell if you choose to use that as the shell, and that's the default. And then, of course, there's all these other processes like BGP and others, but for the most part, it's just a Linux-based system. And so that means it's programmable in every way that you'd expect, including having the ability to run containers or run Docker or run Docker and containers on Docker, to be able to do Kubernetes on the system. And there's all sorts of things that you can do. And that we'll get to that point, but one of the things that you can imagine here is then having the Benu software running on the switch itself as an agent, and then communicating directly with the hardware through the SDK is the most advanced example of what we can do. And we've not implemented that just yet, but it's something that we would be able to do in the future. And that just shows the power of the solution, both jointly and just at the base of the EOS operating system that we're using. It's optimized for spine leaf, but more importantly, it's optimized for scale. It's optimized for automation. So all the key capabilities that are needed in a modern environment, especially in a broadband environment where you have many thousands of users or tens or hundreds of thousands across the whole footprint, perhaps even millions if you're large enough, being able to automate and control all those users is a necessity. There's just no way that you can do anything manually there. And you need to have large scale monitoring in order to do things like billing and to be able to offer more advanced services, not just billing, but also things like if you're going to do parental control and you're going to be able to indicate how much traffic was sent to a particular site or how many times was a particular packet rejected, then you need to be able to monitor at scale as well. And then of course, certification is critical because as you come up with new ideas, new features get built, new software versions are deployed, and you need to be able to certify the software quickly so that you can get that agility, that service velocity, and that service creation ability really has a bottom line impact on the business so that you can beat your customer or your competitors to market. Next slide. So we have two platforms that are germane to this discussion. Both of them are in the fixed format kind of configuration. So although we have very big and modular systems, we think that it's better to be able to deploy smaller systems that have a little bit lower blast radius, and then be able to scale them up with potentially added hardware if needed to do things like put them on an optical ring, for example, or to provide some kind of pluggable PON capability. And it's generally better to do that on a smaller system. It's also more cost effective. And by the way, these smaller systems are nothing to slouch at. I mean, we have, for example, our most recent 7280 R3 series has up to 24 by 400 gig wire speed ports. So that gets you 9 non-blocking, approximately 10 terabits per second with 2.5 million routes. It's probably more than the broadband requirements for almost every provider in the world in one platform. And if there are providers that have larger than 10 terabits, maybe there's ones that have 20, 30, or 40. I mean, put it this way: the number of switches that are on this slide here probably can account for most of the broadband capacity of almost every provider. So it's not a bandwidth thing. It's really about being able to offer the services and being able to have a low cost of entry. We could do that with these systems. The 7280 is based on the Jericho 2 chipset. So it's got advanced features like HQAS and really scalable algorithmic ACLs, EVPN, MPLS segment routing. So for the more sophisticated operator who wants to offer multiple services, including these broadband services, then this is the right platform. Other operators have different requirements that may include being able to do things like carrier grade NAT, be able to do some kind of server load balancing, and also be able to provide broadband access, but don't need all the additional capabilities like maybe segment routing or perhaps hierarchical QoS. And in that case, the 7170 series that we put out, which is from based on the Tofino chip from the company formerly Barefoot, now part of Intel. That's a highly programmable chipset. It's got a high degree of new capability. The programmability is through the P4 language, so it's extensible by the operator if you have the ability to add new services. Both of these platforms are capable of supporting this virtual BNG as an extension. And as we start to develop the capability, we'll be able to have the BNG not only associated with the 7280 or the 7170, but directly program it through either the eAPI or through the SDK to actually onboard and offboard subscribers as they come online. Next slide. So what we think about with our solution set here and where we started to engage with Ben is we started to see this convergence. There's a lot of technologies converging. Obviously, Ethernet has become the dominant layer 1 and layer 2 technology. Obviously, the traditional technologies from the past are long gone. Most of the traditional provider transport technologies aren't in use anymore or rarely in use, and that includes the whole TDM hierarchy and all the other traditional L2 protocols, ATM frame relay, SMDS, et cetera. And even the technology that goes into things like modulation and encoding of information has now started to converge because it's becoming more and more. It's almost like merchant silicon. The cost to do fancy modulation and coding schemes is a big factor, especially at scale and at higher speeds. So having a singular or common set of technologies allows an economies of scale that is necessary to be competitive and to be attractive in the market that continues to grow at the pace that it grows. So while all the technologies on the right have some fundamental differences, obviously the air interface is different than a wired interface, and XG.fast is twisted pair, whereas NG-PON is optical. A lot of the modulation schemes, OFDM, for example, and the fast Fourier transformations that are done at the digital signal processing level are very much the same. And what's happening on the left as you move towards the core is it's all converging towards Ethernet. So if you go to the next slide, you'll see what I mean here. And when we think about all these technologies, Ethernet becomes the central kind of transport tech, and then that provides a seamless access and interface into this next generation edge compute capability, which is where a lot of this network functionality is now being moved, right? So you're seeing this virtualized BNG. We move that into like a mobile packet core or into an edge data center or central office environment. And then, so you have Ethernet, aggregating all these different access technologies and then transporting this traffic right into an Ethernet based data center. So what better than to think about, well, how can we leverage all this Ethernet hardware that's being used to switch traffic and provide some kind of acceleration across the board for all the different access types in this new model. And if you go to the next slide, we can see exactly what we're doing here. So when we think about this new edge fabric, there's a variety of different pieces that we need, but two of the things that I think are most important are service agnosticity. So it's L2, L3, MPLS, segment routing, lots of different gateway functionalities. All of them are sitting in this new fabric environment. Ethernet centricity is key, right? Because now we have different speeds and feeds, but the same transport technology. So all the behaviors are the same. And then it has this CUPS capable NFV. So what we're talking about here is this rapid and rich programmability from the service to the network layer so that we can really separate the functionality where it needs to be separated. Today, these edge compute data centers are relatively constrained in terms of power and cooling and even space, right? In many cases, these are in traditional closed environment vaults or contained environment vaults. Sometimes they're in the base station in huts under a cell tower, for example. They have no air conditioning. They're enclosed so they don't get wet, and they have some air filtration. But generally speaking, if you were to open up one of these huts in a place like Arizona or something like that, it might be upwards of 60 degrees Celsius inside the room, which is almost unbearable to be inside. But the switches and routers can still run in that environment. Even some of the servers can as well if they're designed for it, but you certainly don't want a lot of them. So you want to be able to optimize the functionality for what it's best applied to. And if we have silicon that can forward packets and parse and process packet headers at very, very high speeds relative to what we could do at x86, it doesn't hurt us to offload some of that functionality to the hardware, thereby freeing up additional resources in the x86 domain for things like advanced deep packet processing, or perhaps even reducing the number of servers that are needed. And that's something that generally will have a huge impact on overall cost because they are the dominant cost and the dominant power requirement and cooling requirement inside of these environments. Next slide. So what we're thinking about here and what we've been doing with Benu is effectively a hardware offload. So when you think about all these edge compute apps, and obviously there's virtual baseband units and virtual user plane functions and CG NATs and load balancers. There's also a subscriber management gateway or a broadband network gateway functionality that's been virtualized in these edge compute environments or in data centers in general. x86 packet processing is so relatively costly at volume when you compare it to what you can get in silicon. So what we proposed and what we're doing with Benu is to be able to have, for example, a subscriber authenticate through a control plane session where we pass the traffic through from the switch, the Ethernet layer and the access layer through the switch up into the BNG. But once the user is authenticated, for example, or once a flow starts to flow that's maybe very high bandwidth and very stable, like like a video flow, for example, on Netflix, let's say 4K video, about 15 megabits per second downstream, 2 hours long, nothing changing in the tuple itself, that the source test pair. There's no reason for that packet to continue to be processed in the x86 domain because it's costly. So what we do is just push that flow down into the switching layer and whitelist that as a cut-through switched flow. And by doing that, you get this sort of bump in the wire application offload, where regardless of what the application is, eventually, at its very primitive level, there is some source destination or some match action pair. So you match some stuff and you do some action. And that's ideally what, you know, a switch is able to do. In fact, this is a very SDN-like approach to this, this particular problem, where you have, you know, a control plane that, you know, could do all the smart stuff like authenticate a PPP user and do chat authentication and handle all that sort of session level behavior. But once the packets start flowing, there's no real reason necessarily to continue to process those packets in x86 if there's no further capability that you want to impose. So if you wanted to do deep packet inspection, or if you want to look for, you know, some kind of, you know, virus control or whatever that would require, you know, scanning the packet payload, for example, for signatures, you know, that's hard to do in hardware. That you can do in x86. But if it's just passing, you know, source IP, dest IP, you know, and changing the MAC address on the outbound side, for example, that's a very fundamental process of almost every piece of network silicon. Why not just do it there? Next slide. So when we think about this and we summarize these cloud principles that we're applying to this transformation at the edge, we think about an edge compute cloud. We think about the traditional rigid architecture, and now we're talking about these scale-out architectures, that, you know, leaf-spine construct that gives us scale for, you know, us to be able to deploy as many of these functions as we'd like. You know, we simplify the operation here, and that makes it automatable. So you have a simplified subscriber model, you have a simplified programming model, and then either you program all the users or some of them, whichever you do. It's a much more simple operation because it doesn't require this heavy-handed, sort of overly policy-driven control mechanism. Now, you can drive as much policy as you want, but the hardware forwarding that we apply here is very simple, just a simple match action pair. The service delivery becomes software-driven, yet hardware accelerated. So this is the flexibility is much more there now, because now we can leverage the full capability and the full fungibility of the x86 assets, where we can add features and in software relatively quickly. But then where we want to be able to accelerate and where the hardware supports it, we can push down that acceleration into the hardware very quickly at scale with a high degree of programmability. And then because we have such a modern operating system, at least in our case, and I think it's the same applies to the Benu case, where they can provide all this visibility as well, in concert together with our state streaming based architecture, we can pass all of the information that's needed. So all the flow counters, all the number of authenticated users, all the packets per subscriber, all the things that you need to do rich billing and rich analytics will be available to you, not just from x86, but from the hardware domain as well. So this gives you that real-time digitized customer experience that's necessary in order to transform your service provider business in this day and age where this need for digitization in order to capture more attention, to be able to capture more revenue, is just fundamentally necessary in order to be successful in this market. And that's what I think together we're able to bring here. Mike, I'll go ahead and give it back to you.
Okay, thanks, Christian. All right, so we've talked about using, you know, a switch that's probably going to be there anyways, right, to aggregate traffic from all the various access networks and, well, OLTs and, you know, DSLAMs and whatnot, and leveraging that for the hardware offload, particularly for those flows that don't require a lot of software-based processing, and the benefits of doing that and having that architectural flexibility. Now we want to transition to talking about how can you maximize your return on investment by looking at the services side and adding new capabilities that would be valuable to your customers. So there's, you know, in an architecture where you have the BNG aggregating the access traffic, there's sort of two additional things you can do is layer on, you know, home security capabilities or home services. And then there's another level, which is adding device level services, where you're doing policies on individual users or devices. It's particularly valuable for teleworker or IoT types of applications. And we want to get into a little bit more detail about how we do that in this solution. So one of the things that we do is we provide a service management cloud. And this has a pretty broad set of tools, as you can see here on the left. We have an admin manager, an operations manager. We have the boss tool, which is our Benu Operations Subscriber Simulator, which is specifically for measuring the user experience of your subscribers. And we also have a site manager for managing sort of the profiles for different types of homes and businesses. And then we have a home and business user self-service portal where users, the subscriber can log in and they can set up various policies. They might say, they want to restrict IoT devices from coming onto their network unless they specifically approve it, right? So that they know what's coming onto their network. So if we click through here, Shirsha. So just talking about the services in 4 areas, although there's other areas that you could add services on. One is home security, like I mentioned with IoT, parental controls, so controlling which web content could be viewed by children, but also managing their time duration online, perhaps maybe setting a bedtime schedule where there's no access after a certain hour, and then of course getting usage reports and alerts. Teleworker, we've talked a little bit about that. Primarily sort of the importance there is keeping the traffic prioritized appropriately, as well as potentially adding additional security services, more advanced security services that the business would want to use. And this is an offering that can either be sold to the end consumer or it could be offered to an enterprise to basically enhance the security and the quality of service for their employees that are working from home. And that allows you to sell, an enterprise level service. And then the last one is guest Wi-Fi. So allowing people in their homes or businesses, small businesses, to set up a guest Wi-Fi network, which keeps the traffic completely separate from their home or business network. And not only is convenient, but is a very useful service, particularly if you're doing Airbnb and you're renting out your home. You really don't want those guests coming onto your home network. And the guests really want to know that they're on like a separate sort of private connection. So these are both very valuable capabilities. So if we go to the next slide, Shirsha. So just so you know, there's a lot of user interfaces that are already designed. And so it's not like you have to go and build this stuff yourself. It's already hosted in our clouds such that you don't really have to implement anything. And this really cuts down on the time to market for an operator that wants to implement these things. It really cuts down on the investment that's required and allows you to offer something that is above and beyond, what the customers have seen before and drive additional revenue or additional stickiness to reduce churn. So what does that mean to you in terms of all these things we've talked about? How does that improve a service provider's business? Let's talk specifically about that. Well, architecture, flexibility, and performance generally is going to reduce cost. It's going to reduce backhaul costs. It's going to provide lower latency, edge services, and operational efficiencies. And you also eliminate that hardware lock-in that has traditionally been a challenge for a lot of carriers where they've bought proprietary hardware software solutions that are generally inflexible, and you're sort of bound by what that vendor is providing. On the next slide, we talk a little bit about here how the services can drive either reduce costs because you're consolidating network functions. It can also drive new revenues and the agility to respond to the market and provide new capabilities very quickly. And so, obviously, this is going to help improve any carrier's business if they can provide these services at a low cost and very quickly. So just to wrap it up, because we want to make sure we have time for questions, I think the question what you want to be thinking about here is what if your future network could do these things? So deliver ultra-fast broadband, that not only gets you qualified for, you know, government funding if you have a government that is providing that kind of support for faster broadband speeds, but also enables new and innovative services. And can you consolidate some of your network layers so that you've got a more space and power efficient network, and probably also easier to manage, and therefore create efficiencies in your resources and be able to expedite delivery of those services and providing those services to customers in homes and businesses and even down to the device level. So, you know, hope you enjoyed the webinar today. You know, we've got two very capable companies with a long track record of providing great products, both you know, within the software and the hardware side of things, and we're pretty excited to bring this solution to market.
Okay, so if anybody, if you guys don't have any further questions aside from some of the more specific ones that we can chat about offline, I will let you guys have the 3 minutes of your day back. Thanks so much for joining us today. I know that we went through a lot of technical details, which is great. So if you guys have any questions about that, don't hesitate to reach out. Christian, thank you for joining us. It was a blast.
Thank you very much, Mike, and I'm happy to be here, and looking forward to hearing if there are any other questions and what we could do to help better get this thing moving.
Awesome. Sounds great.